Hi guys, I welcome you to this episode of Learning Physics with me, and today I would like to take you to another episode. I think this is going to be part 7. IBM is my name, and without wasting time, I would like to take you to part 7 of the solved past paper questions. So I'll move to the document. I think in part 6 we stopped on this page here, and I want us to start from the same page. So I'll use blue. Okay, so in part 6 we stopped on this question here, and I think we said the answer was B. So I will start with the next question. This is part 7. The derivation of the pressure equation delta P is equal to rho G delta H uses a number of relationships between quantities. Which relationship is not used in the derivation of this equation? So to derive that equation, of course, rho is density, that is mass over volume. This could be used. Then potential energy is mgh. This is mgh. Pressure is force over area. We could use pressure as force over area. So if pressure is equal to force over area, this is going to be used. And the force is going to be equal to mg. Then we divide by the area. So we shall use the weight, mg. Then the mass is going to be density times volume, density times volume. Then we multiply this by G over area. So this the density equals mass over volume has been used. So it means this one will not be used. So the answer is going to be B. B is not going to be used. So we shall use the one of density, pressure, and the one of weight to derive the expression for pressure, because in addition to that, so pressure is going to be equal to density, volume is cross-sectional area times h, or times change in h, then times g divided by cross-sectional area, where cross-sectional area cancels, so that the pressure becomes density delta h times g. So it means the one of potential energy is not used. Two blocks of mass m and small m are joined by a thin string which passes over a frictionless pulley. The acceleration of free fall is g. What is the acceleration A of the two blocks? So the acceleration of free fall is g. So there must be a tension in each of these. So the tension here, if the acceleration is downwards, this one is moving upwards, this one is moving downwards. So the tension here must be pointing in that direction. That is going to be the tension. And this is moving upwards. Remember, the tension pulls away from the object, so the tension here is also in that direction. Okay, but this tension is the same because it's the same string. So let's consider the mass on the left hand side. So considering the mass on the left hand side, the resultant force is going to be mass times acceleration. This is going to be given as m times g for the big mass minus the tension downwards. That is the resultant force for the first one. Then for the second one, the tension is still upwards. So we shall say tension T minus. Okay, let me start with the resultant force MA. So the resultant force is going to be small mass m. What has happened? So it will be small mass m, then times small a. This is going to be equal to tension. Remember, the tension is upwards, so it will be T minus the weight of the small mass m downwards, which is going to be m times g. So if I add the two equations, t cancels out. So I have a into capital M plus small m being equal to t has cancelled out. If I add these two equations, t has cancelled out. So I remain with capital M minus small m because I'm adding. Then in brackets I have g. So if I make A the subject, then acceleration is going to be equal to capital M minus small m. This is into G divided by capital M plus small m. So this is going to be our expression. That means our answer is going to be simply B. The diagram shows a block of copper suspended in water. The block experiences an upthrust from the water. Which statement is the basis of an explanation for this upthrust? Which statement is the basis of an explanation for this upthrust? Okay, so we know that upthrust is given by the cross-sectional area times the difference in pressure. So the upthrust is going to be the cross-sectional area. Of course, pressure is going to be density times G times change in height. So this will be density times G times the difference in height. So the question is, which statement is the basis of an explanation for this upthrust? Of course, upthrust is due to the difference in pressure. Pressure increases with the depth. When you go to as the depth increases, the pressure increases. So the pressure at the bottom is greater than the pressure at the top. So let's see. Copper is more dense than water. This does not explain that. The area of phase R is greater than the area of phase S. Of course, pressure in liquid will not depend on, okay, it will depend on the cross-sectional area, but pressure due to the liquid does not depend on the cross-sectional area. Which statement is the basis of an explanation for this upthrust? Because they said the body experiences an upthrust from the water. It's not because of that difference in area. The density of water increases with depth. The density of water increases with depth. This is not true. The pressure of water increases with depth. So because the pressure increases with depth, then there is a difference in pressure at the bottom and the top. So there is an upthrust. So the answer is going to be D. The difference in pressure at the top and the bottom, since pressure increases with depth, is the one which is best going to explain the origin of upthrust. The diagram shows a solid cube with a weight W and sides of length L. Weight is W, sides of length L. It is supported at rest by a frictionless spindle that passes through the centers of two opposite vertical faces. One of these faces is shaded. Okay. The spindle is now removed and replaced at a distance of a quarter L to the right of its original position. Okay, it is now moved to a quarter L to the right of its original position. So here it must have been in equilibrium if it was pulled at the center. Now, if it is moved to a quarter, so the weight is acting at the center point and the weight is given as W. So a moment which is going to be anti-clockwise must be acting along the line of the spindle because it has moved away from the center. So the weight causes an anti-clockwise moment about the spindle, and that moment or that torque is going to be the weight times the perpendicular distance, which is L over 4. So let's see the question. When viewing the shaded space, what is the torque of the couple that will now be needed to keep the cube at rest? So since the weight causes an anti-clockwise moment, so it means to balance this one, we need another clockwise moment to counter the anti-clockwise moment. And they should be equal, so it should be W times L over 4, but it should be clockwise because the resultant moment is anti-clockwise. So to balance it, we need a clockwise moment to counter it so that it remains at rest. So the answer is going to be B. It will not be A. A is what we obtain. We obtain anti-clockwise. So to balance the anti-clockwise, we need a clockwise moment. Two rigid steel beams X, Y, and YZ are fixed at their lower ends and are hinged at Y. Each beam is inclined at 50 degrees to the horizontal as shown. A weight of 4.0 times 10 power 4 newtons hangs from Y. The structure is in equilibrium. So when we see equilibrium, it means the resultant force should be 0, the resultant moment should be 0. So there must be forces in these beams. So since this is acting downwards, then these forces could be acting upwards. So I'm going to resolve these forces vertically upwards. I'll resolve these forces vertically upwards. What is the force exerted by each beam on the hinge at A? The angles are the same, so this force and this one will be the same. So I'm going to resolve these forces F vertically upwards using 50 degrees, resolving upwards. That will be F sine of 50. This one also be F sine of 50. So these two forces are acting upwards. So it means that I will sum them up and I will get 2F sine of 50 should be equal to the force downwards, which is 4.0 times 10 power 4. So I just press my calculator to get F. So F is going to be 4 exponent 4 divided by 2 sine of 50. So this means F is going to be 26,000 approximately. So this is approximately 26,000, or which is 2.6 by 10 power 4 newtons. So it means here the answer is going to be A. Air is trapped inside a glass bulb. Air is trapped inside a glass bulb, which is immersed in water and attached to a U-shaped tube containing mercury. The density of water and mercury are ρW and ρm respectively. The surface of the water is open to the atmosphere. So that means there is atmospheric pressure on one side, on the surface of water, where atmospheric pressure is P. Okay, let's see the question. The acceleration of free fall is G. What is the pressure of the air in the glass bulb? Okay, pressure of the air in the glass bulb. So note at first of all that the liquid on the side of the air in the glass bulb is higher than the liquid on the other side, meaning that the pressure on the left hand side must be greater than the pressure on the right hand side. So to find the pressure of the air, I will simply get the atmospheric pressure, or I will first of all find the pressure on the left hand side. Let me call it P on the left hand side. Because on the left hand side it is open, so on the left hand side we have pressure, we have atmospheric pressure plus the pressure due to that liquid, that is going to be H rho times G. Pressure due to this liquid here, which is that liquid there. So this is going to be P plus H rho G. So this is going to be for water, density of water, and G. Then the pressure due to air should be equal to the pressure on the left hand side minus H, or the pressure due to the liquid in the tube. So this is going to be, because pressure on the left hand side is atmospheric pressure plus the pressure due to the liquid due to the water whose height is HW, then it means this is going to give us P plus HW rho W times G, then minus, no, this is HM, because this height here is HM. So this is going to be HM, and of course density remains the density of inside the tube we have mercury, so this is density of mercury. So this is going to be minus HM density of mercury times G. So I don't know whether this is clear. If I want the pressure due to the air here, I must get the pressure on the left hand side minus the pressure due to the liquid, because the pressure on the left-hand side is above the pressure due to the air by this height, by the pressure due to this height here, which is given by height of the material, density of the material, then times G. There is excess pressure on the left-hand side than on the right-hand side, which excess pressure is given by this quantity here. So if I want to find the pressure due to the air, I must get the pressure on the left-hand side minus the pressure due to this quantity here. But the pressure on the left-hand side alone is atmospheric pressure plus the pressure due to the liquid of the water, whose height is HW. So when I simplify this, I will check first of all the answers given. Okay, we have, I think the answer is going to be, it will not be C, it will not be D, because atmospheric pressure must come into play. So it means the answer there is going to be B. This is P plus HW rho WG minus HM rho MG. So the answer is going to be B. A ball of mass M is thrown up to a height h in air with initial velocity v as shown. Air resistance is negligible. The acceleration of free fall is g. What total work done by the gravitational force on the ball during its flight from P to Q? The gravitational force. We want the gravitational force. So the gravitational force, the total work done by the gravitational force W is going to simply be the gravitational force times the displacement, the vertical displacement. So it will be the gravitational force times the vertical displacement. And since the vertical displacement here is zero because it moves upwards, if it moves upwards, positive h, it moves downwards, negative h. So it means the vertical displacement is zero. Displacement is zero, so that means the work done is going to be zero. So the answer is going to be A. Total work, because it is total work done, then the total work done is going to be zero, because work done is force times distance in the direction of the force, and distance in a specified direction is displacement. When we move from P back to Q, which is where Q is on the same horizontal line with the P, it means that the displacement is zero, therefore the work done is going to be zero. So the answer is A. Two forces, each of magnitude F, act along the edges of a rectangular metal plate as shown. The plate has length A and width B. What is the torque about point P? The torque about point P. So remember, torque is the product of the force and the perpendicular. Since these are forming what we call a couple. These are forming what we call a couple, and we want the torque about point P. So since they are forming what we call a couple, then a couple is the product of one of the forces times the perpendicular distance between the two forces. So the torque produced by a couple at point P is going to be the product of one of these forces times the perpendicular distance B. So that means the answer is going to be B. We don't need to mind about finding this distance and again finding this distance. These are constituting a couple because first of all they are equal in magnitude, they are parallel to each other, their lines of action never meet, they point in opposite directions, so they constitute a couple, which is a product of one of the forces and the perpendicular distance between the two forces, so the answer is going to be B. A solid sphere falls at constant terminal velocity in a liquid. The three forces acting on the sphere are shown in the diagram. Not to scale, it's not to scale. Okay, how are the three forces related? So it is moving, it falls at constant terminal velocity, which means the resultant force must be zero. The resultant force must be zero, so it means the upthrust upwards plus the drag force upwards should give us the weight downwards, or the weight minus the upthrust should give us the drag force, or the weight must minus the drag force should give us the upthrust. Therefore, let's check the answers. So this means our answer is automatically going to be C. The weight minus the upthrust gives us the drag force. So the answer is C. Remember, I have done this because for at constant velocity, acceleration is 0, resultant force is equal to 0. So it means the forces in the opposite directions should be balancing. That's why I added upthrust plus the drag force to get the weight. A thin horizontal plate of area 0.036 meters squared is beneath the surface of a liquid of density 930 kilograms per meters cubed. The force on one side of the plate due to the pressure of the liquid is 290 newtons. What is the depth of the plate beneath the surface of the liquid? Depth of the plate beneath the surface of the liquid. Okay. So first of all, we know that pressure due to a liquid, or pressure is force over area, but pressure due to the liquid is going to be H density times G. We have the pressure, we have the force on one side of the plate, which is 290 newtons, and we have the area. So we shall simply say that 290 divided by the area, which is 0.036, should be equal to the depth. Density is 930, G is 9.81. I'll just press my calculator to find H. So I have 290 divided by 0.036. Then I will divide this by open brackets 930 times 9.81. So this gives me 0.88. So H is 0.88 in meters. So the answer is going to be A. A horizontal cylinder of cross-section area A is fitted with a frictionless piston and contains air at pressure P. It is immersed in hot water and the length of the air column increases from X to Y. The pressure P is constant. The pressure P is constant. Okay. Which equation represents the work done? Of course, we know that work done due to an expanding gas is equal to pressure times change in volume. So this is going to be the pressure is constant, volume. So for the change in volume, we have the length changes from X to Y. So the change in length is going to be Y minus X, that is change in length. Then the cross-sectional area was given as A. So the volume is going to be, the change in volume is going to be the cross-sectional area times Y minus X. So this is going to be A into Y minus X. So our answer is going to be C. The diagram shows a uniform beam PQ. The length of the beam is 3 meters and its weight is 50 newtons. So 3 meters, weight 50 newtons. It is uniform, its weight acts at the midpoint. The beam is suspended on a pivot 1 meter from end P. A load of weight W is hung from end P and the beam is in equilibrium. Okay, so the weight is at the midpoint. The weight of the beam is at the midpoint. So I'll put 5 newtons here. 50 newtons at the midpoint. So from here to the other end is going to be 1.5 meters because it is the midpoint. So that means this distance here should be 0.5 meters. So what is the value of W? Taking moments above the pivot, W times the perpendicular distance should be equal to the weight 50 newtons times the perpendicular distance, which is 0.5. So when you press your calculator, 50 times 0.5 is 25. So the answer is going to be A, because it is W times 1. So the answer is A. Two forces, each of magnitude F, act at points V and W on an object. The two forces form a couple. The shape of the object is a right-angled triangle with the sides of lengths X and Y as shown. Which expression gives the torque exerted by a couple? Remember, the torque exerted by a couple is the product of one of the forces times the perpendicular distance between the two forces. So the perpendicular distance, if I prolong this line the other side and I prolong this one this side, you notice that the perpendicular distance is y. So this is going to be times y. So it means our answer here is going to be A. Product of one of the forces, no, not A, it is B. It is the product of one of the forces and the perpendicular distance. So the answer is going to be B. The perpendicular distance between the two forces is y, not x. So the answer is B. A giant squid of length 20 meters is vertical in seawater with the top of the squid at a depth of 8 meters. The density of seawater is 1050 kilograms. What is the difference in pressure between the top and bottom of the squid? Okay, so we have the density. We have it has a length of 20 meters. A giant squid of length 20 meters is vertical in seawater with the top of the squid at a depth of 80 meters. The top of the squid is at a depth of 8 meters. Okay. So we know that pressure due to a liquid is given by the depth times density times G. So this is simply going to be because a giant squid of length 20 meters is vertical in seawater. The top is at a depth of 8 meters. What is the difference in pressure between the top and the bottom? So I will draw, of course, I will just put here, let this be the surface of the water, this will be the sea. So a giant squid of length 20 meters, the length of the squid is 20 meters. And then the top of it is at a depth of 80 meters. So now pressure due to the difference in the pressure is going to be pressure at the top, P1, subtracted from the pressure at the bottom, P2. But remember, pressure the P2 is going to be equal to density times G times the height H2, which is going to be 8 plus the height H2 is this height here, which is 8 plus 20. Then P1 is the one at the top, which is density times G, and the height is H1, which is this height here, which is 80 meters. So if I want the difference in the pressure, it will be density times G. I will subtract the heights, and this will only be 20. So this is going to be 20 times G, which is 9.81, times the density, which is 1050. So we just take the length of the squid. So pressing my calculator, I have 20 times 9.81 times 1050. That is 206,000. That is 206,000. So that means my answer is going to be B. Forces are applied to a rigid body. The forces all act in the same plane. In which diagram is the body in equilibrium? So first of all, in equilibrium, there should be no resultant force. We can begin by that one. Here, there is no resultant force. There is no resultant force. Here, there is a resultant force upwards, so that is not in equilibrium. A half F, that is 1F. Here, there is no resultant force. Now, we have finished to check resultant force and we have eliminated C. So now we check resultant moment, because we want one where there is no resultant moment. So this one causes a clockwise moment, which is countered by this one, but there is a moment, and this one is acting at the center, so it causes no rotation. So this one, the resultant torque here is going to be 0, because this clockwise moment is countered by the anti-clockwise moment, and this F is acting through the center, so it causes no moment, so the torque here is 0. This one is countered by this one. These ones have no moment. F and the ones at the center have no moment, but this is causing anti-clockwise. The resultant is anti-clockwise, so this one is out. Then D. This one has no moment because it's acting at the center. This moment is countered by this one. So these ones cancel out, but this one is not counted. So this is an anti-clockwise moment. So it means our answer is going to be A. Because for A, there will be no resultant torque. So the answer is A. A solid metal cylinder stands on a horizontal surface as shown. The cylinder has length x and cross-sectional area A. The cylinder exerts a pressure P on the surface. The acceleration of free fall is g. Which expression gives the density of the metal of the cylinder? Which expression gives the density of the metal of the cylinder? Okay. So we know that we know that pressure is equal to H times density times G. Of course, the pressure exerted by the cylinder will simply be, the height will be simply X. So this will be equal to X times the density times G. So that is the pressure. So we want to make the density the subject. So density is going to be pressure divided by X times G. The density is going to be pressure divided by Gx. So this makes our answer to be B. Okay, so the answer is B. So a trailer of weight 30 kilonewtons is attached to a curb at X, as shown in the diagram. What is the upward force exerted at X by the curb on the trailer? Upward force exerted at X by the curb on the trailer. So of course, at the points of contact here, there is normal reaction, which is going to be the same here. There is no more reaction there, so I'll call these forces F. Since there should be equilibrium in the vertical, then it means the upward force exerted by the upward force exerted or the normal reaction at the points at the wheels should be equal to the weight downwards, which is going to be 30 kilonewtons. So I will say that F plus F should be equal to 30 kilonewtons. So it means 1F is going to be 15 kilonewtons. So the 30 kilonewtons should be equal to the weight. The 30 kilonewtons should be equal to the force exerted upwards by the wheel, or the total normal reactions by the wheel. So what is the upward force exerted at X by the curb on the trailer? So the upward force exerted by the curb on the trailer should just be equal to one force, which should be just equal to the normal reaction force produced by, or the normal reaction force by just one wheel, or at the point of contact with just one wheel. So the answer is going to be B. The 30 kilonewtons should be equally shared in the wheel or by the wheel. So expect that the force exerted at X by the curb on the trailer should be equal to the normal reaction by just one wheel. So the answer is going to be B. The diagram of a solid metal sphere is measured using a micrometer screw gauge. It is a micrometer screw gauge. Of course, this measures in millimeters. The diagram shows an enlargement of the shaft of the micrometer screw gauge when taking the measurement. The mass of the sphere is 0.450 grams. What is the density of the metal used to make the sphere? Okay, we want to find density. We are not taking measurements alone, we are finding density. So first of all, I'll first find the diameter. So this is This is going to be 4.5. So this is going to be 4.5 plus, I think this is 31. This one here is the most important mark, 31. So that is going to be plus 31 divided by 100. So this gives me a 4.5. 4.5. So this is going to be 4.81. 4.81 in millimeters, because this one measures in millimeters. Okay, so it means the diameter is going to be 4.81 times 10 power minus 3. So let's check the density, since density is mass over volume. So density is going to be mass divided by volume. And remember the volume, it is a metal sphere. The volume of a sphere is going to be 4/3 pi r cubed. If I remove pi, I don't want to find radius, so I will just put in diameter. When I remove, I know that r is diameter divided by 2. So this becomes diameter divided by 2, that is d squared. Okay, this is going to be 4/3 pi d power 3 divided by 2. 2 power 3 is going to be 8, so this one cancels. So it becomes pi d cubed over, because this is 2, so over 6. So that will be the volume. So density will be equal, the 6 goes up, so it becomes 6 times the mass, which is 0.45 by 10 power negative 3 divided by the volume. Remember, the volume is pi d squared over 6, and the 6 has gone up when I divide. So in the denominator, I only have pi times diameter, which is going to be 4.81 times 10 power minus 3. This is raised to power 3. If it is hard for you to use this expression, where d is radius is d over 2, you can just divide the radius, the diameter, by 2, and you substitute in this expression here. So here I will just press my calculator. So that is 6 times 0.45 exponent minus 3 divide by, open brackets, half pi, I'll say divide by pi, open the brackets, 4.81 exponent minus 3. This is raised to power 3. So this is giving me 77223. 77223. So it means my answer is going to be C. 7720 kilograms per meters cubed, to 3 significant figures. A light rigid rod XY has an object of weight W fixed at one end. The rod is in equilibrium, resting on a roller at Z and a vertical wall at X. It is in equilibrium. The roller exerts a force R on the rod as shown. The diagram shows the directions but not the magnitudes of the forces R and W. What is the direction of the force on the rod at X? Because the body is in equilibrium, when I prolong these forces, there should be a force which is acting at point X to counter or to balance these ones. Remember, the resultant moment should be 0 about point X, and the resultant torque, the resultant force should be 0, and the resultant torque should also, the resultant moment should also be 0. So the simplest way I'm going to find the direction of the force on the rod at X, I'm going to prolong these forces, and I see where they meet, it means the other force should also meet at that point. So I'll prolong R backwards because I can't take it forward. If I take it forward, it will never meet with W. So I'll take R backwards, and I'll take a W downwards. Okay, so maintaining their directions, W is downwards, and R is in that direction. So I'm going to draw a line from X to meet where these two forces meet so that I get an approximate direction of the force at point X. So this is going to be from this point to this point here. So most probably there's no force pointing towards X. So this one is wrong. This one is wrong. The force to X is not horizontal. That's wrong. So this means the force at X is only going to be this. So this force is going to point in this direction here. And I think it makes sense because if R is supporting the force W and R causes an anticlockwise moment, then there should be a force. There should be a force which, when added to R and W, the resultant should give us 0. So it means the force at X should be pointing this direction. So the answer is going to be D. I just use the simple analogy that these three forces should meet at the same point if we prolong them. In a large container in an oil refinery, three oils of different densities are mixed. No chemical activity occurs. The mixture consists of 200 kilograms of oil of density that, 1,500 of density that, 4,000 of density that. I think we answered this question more than 2 times. Okay, what is the density of the mixture? So without wasting time, we know first of all that the mass is going to be density times volume. And the density of a mixture, which is the total density, is going to be the total mass of the mixture over the total volume of the mixture. So I'm just going to substitute. Here they have given us mass and density. I'll always be multiplying this to get the volume. To get the volume, I'll simply divide density by mass by the density every time to get the volume. But they've given us the mass, so this is simply going to be density of the mixture is going to be the total mass, which total mass is 1,200 plus 1,500 plus 4,000, that is total mass, divided by total volume. So to get volume, every time I'll always be dividing mass, I'll always be dividing the mass by the density to get the volume. Volume is going to be mass over density. So for the first oil, this will be 1,200 divided by 1,100 plus. For the second oil, this will be 1,500 divided by 860 plus. For the third oil, this will be 4,000 divided by 910. I don't need to press a calculator for this because we have done this many times. You can check your calculator. But me, I'm very sure the answer is 9.7. So the answer is A. Two coplanar forces act on the rim of a wheel. The forces are equal in magnitude. Which arrangement of forces provides only a couple? Which arrangement provides only a couple? So for a couple, the forces shall never meet. This one is out because if I prolong these ones, the line of action meets. These ones are pointing in the same direction, so they don't constitute a couple. These two forces, for a couple, the forces must act in the opposite direction. This is out. This one, the lines of action will meet if we prolong them, so this is out. These ones, the lines of action will never meet and they're acting in opposite direction, so the answer is D. The density of air on the Earth decreases almost linearly with height from 1.22 kilograms per meters cubed at sea level to 0.74 kilograms per meters cubed at an altitude of 5,000 meters. Atmospheric pressure at the Earth's surface on a particular day is 100,000 pascals. The value of G between the Earth's surface and an altitude of 5,000 meters can be considered to have a constant value of 9.7. So G is remaining the same, but the density is varying linearly. Since it is varying linearly, we can easily find the average density as the most appropriate density for this equation. So the average density is going to be 1.22 plus, I'll say 1.22 plus 0.74 divided by 2 to get the average density. I think this is 0.98. So this is the average density. Since it varies linearly, I can get the average by just dividing by 2. Then I'll find the pressure at the height of 500 meters. So pressure, remember pressure is going to be equal to the depth times density times G. So pressure is going to be, at that height is going to be, this is 5,000. So it is going to be 5,000 times the average density 0.98 times G, which is 9.7. And I'll press my calculator. 5,000 times 0.98 times 9.7. So that is approximately 48,000. So this is approximately 48,000 pascals. That is the pressure at a depth of, the pressure at an altitude of 5,000 meters can be considered to have a constant value of that. So this is the pressure at 5,000 meters. So what will be the atmospheric pressure at an altitude of this? So the pressure due to this height is this, but then we want the atmospheric pressure. The atmospheric pressure at that altitude. So we shall just subtract 100,000 minus that. So the atmospheric pressure at that altitude is going to be 100,000 minus 48,000. And I think the answer is going to be 52,000. So the answer is C. So the atmospheric pressure decreases as you go higher. The pressure due to this height, we have got it as that. But this height, it's like, assuming these were the clouds and this is the Earth's surface. So when you go to a height of 5,000 meters, so it means the atmospheric pressure at that height is the pressure due to this part here. So we first get the pressure due to this height here, and we subtract from because the 100,000 is going to be the atmospheric pressure at this level here. This is the 100,000 pascals. So we get the pressure due to this height of 5,000, which is 48,000. Then we subtract it from 100,000 to get the pressure at that height there. So the answer is going to be C. What is the center of gravity of an object? Of course, center of gravity is a point where the entire weight of the object may be considered to act. So the answer is going to be B. The point at which the weight of the object may be considered to act, that is center of gravity. For a change in depth delta H in a liquid of density rho, the change in pressure delta P is given by this expression here, where it is the acceleration of free fall. What is the equation or principle of physics used? What is the equation or principle of physics used in the derivation of this formula? So first of all, we know that pressure is force over area, and force is going to be the weight over area. The weight is going to be mg over area. Then mass is going to be density times volume, then times g over area. So atmospheric pressure decreases with height. Atmospheric pressure decreases with height. Of course, we cannot, it decreases with the height, but we can't use that to derive that formula. Changing gravitational potential energy is mgh. We can't use this one. Of course, we have used this one here for mass is density times volume. The density of a liquid increases with the depth. The density is uniform. So the answer we are using is, the equation we are using is density is mass over volume. So the answer is C. A submarine has circular windows of diameter 0.3 meters. The windows can experience a maximum external pressure of 660 kilopascals before they crack. What is the minimum external force needed to crack the windows? So we know that force or pressure is equal to force over area, which implies that the force is equal to pressure times the area. So the minimum force here, they gave us the diameter. They have circular windows. So they give us the diameter, and area is equal to pi r squared. Okay, I will just divide the diameter by 2, so I get 0.15 meters. So it means the force is going to be the pressure, which is 660,000, then times the area, which is going to be pi times r squared, which is 0.15 squared. Okay, so 660,123 zeros times pi times 0.15 squared. So this is giving me 46652 approximately. So this is 46653 approximately, which is approximately 47000 newtons. So the answer is going to be A. Four beams of the same length, each have the three forces acting on them. Which beam has both zero resultant force and zero resultant moment? 30 plus 50, that is 80. Downwards, it is 90. So this is the resultant force is not zero. The resultant here is 10 downwards. 28 plus 35, I think that is 63. 63, the resultant force here is 0. This is 106. 106, the resultant force is 0. 112. 112, the resultant force is 0. So we have eliminated A. Now let's check the resultant torque. So we want the resultant torque to be 0. Okay. So if I take moments about where this is acting, this one will not have any moment. But this one will cause a moment which is clockwise, that is 42 times 50. That gives us 42 times 50. That is 21,2100. And this one will cause an anticlockwise moment, which is 70 by 30, which is 2100. So that means the resultant moment is going to be 0, because this will not have a moment if I take moments above this. So the answer is going to be D. You can check the rest. If I take moments around about this point here, this will be 28 times 50 above that point. 28 times 50, that is 1400. When I take moments, so this will be clockwise. This is going to give us anti-clockwise about this point here. So 30 times 35, that is 1050. So there's a resultant moment here which is actually going to be clockwise. So this is wrong. You can check B. B is also wrong. So the answer is going to be D. An air conditioning unit is supported by a rigid beam PQ as shown. Which diagram shows the directions of the horizontal and vertical forces acting on the ends of the beam? Okay. So an air conditioning unit is supported by a rigid beam PQ. So at every point of contact here, there is normal reaction in that direction. And there should be a force which is acting vertically upwards at this point here. The same applies to this. There is a normal reaction here, and there could be a force acting that direction. So the question is, which diagram shows the direction of the horizontal and vertical forces acting on the ends of the beam? So there is a possibility of the beam sliding downwards, so friction is upwards, so that force acts upwards. Of course, this is normal reaction. There is a possibility of the beam sliding away in this direction here, so friction acts in the opposite direction. So the vertical forces, one is upwards, one is vertical downwards, and the horizontal forces, one acts to the left at the bottom, and one acts to the right at the top. So the answer is going to be automatically B. So this one is wrong because the normal reaction does not point towards the object. This one is also wrong because of this normal reaction pointing towards the object. No, not sorry. Normal reaction is pointing upwards, so this is wrong. This one is fine, but this one is wrong because the normal reaction will point downwards. So the answer is B. Concrete has density 2,400 kilograms per meters cubed. Which mass of concrete fills a rectangular space of dimensions 8 by 90 by 1110? Okay. So we want the mass that fills that space. We have the density. So density is equal to mass over volume, which means the mass should be density times the volume. The density is 2400 times the volume. The volume is going to be 8 by 90 by 110. I'll change this to meters cubed, so that will be times 10 power minus 6 to change it to meters cubed. So this will be 2,400 times 8 times 90 times 110 exponent minus 6. So this gives us 190. So this is 190 kilograms. So the answer is going to be B. Which diagram best shows the forces acting on a ball falling at a constant velocity through a liquid? A ball falling at a constant velocity through a liquid. Okay. So at constant velocity, it means acceleration is equal to 0. So the resultant force should also be 0. So of course, this is going to be wrong because when you check the length of these magnitudes, they are almost equal to the length of the weight. That means when you add these two, it is going to be almost twice the weight. So that is not in equilibrium. So here they have showed viscous drag upwards, balancing with a weight. The lengths are almost the same, but it is the forces which act on a ball falling at a constant. It is moving. There's viscous drag, but there's also upthrust. So here upthrust is missing. Here viscous drag is missing because it is moving. So the answer is going to be D. When we add the upthrust plus the viscous drag, we should get the weight. So when you combine these two, the length of these two arrows, you're most likely going to get the length of this arrow here. So this is showing resultant force being 0. So the answer is D. A minimum torque of 20 Newton meters must be applied to the lid of a jar for it to open. The radius of the lid is 4 centimeters. What is the minimum force F that must act on each side of the lid in order to open? First of all, these two forces are constituting a torque. They're constituting a torque. these two forces are constituting a torque because they are parallel to each other and the perpendicular distance between them is going to be 8 centimeters, so 8 times 10 power negative 2. So 20 newtons is the torque. The minimum torque required should be equal to the product of one of the forces times the perpendicular distance between them, which is equal to 8 times 10 power minus 2. Moment of a torque is the product of one of the forces. Moment of a couple or torque of a couple is the product of one of the forces and the perpendicular distance between the two forces. So when I make F the subject and I press my calculator, I have 20 divided by 8 exponent minus 2. So this gives me 250 newtons. So the answer is going to be C. The diagram shows the brake system of a car. The pipes are filled with incompressible liquid. When a force is applied to the brake pedal, the pressure in the liquid increases and applies a force to each of the four wheels. Each of the four wheels, there are four wheels. The area of the piston connected to the brake pedal is 8 centimeters. The area of each piston connected to the brake pedals is 12 centimeters squared. A force of 800 newtons applied by the foot to the brake pedal. What is the force applied to each brake? I want you to notice that pressure due to the liquid remains the same at all points. Pressure due to liquids remains the same at all points. So this one is applying a force of 800 newtons in that direction. And know that pressure is equal to force over area. So looking at the brake pedal, we can find the pressure there. It is going to be 800 newtons divided by the area of the brake pedal, which is going to be 8 by 10 power minus 4 to change centimeters squared to meters squared. I think this is going to be 100,000. I think that is 100,000. 800 divided by 8 exponent minus 4. Now it's 1 million. This is 1 million pascals. So that is the pressure due to the brake pedal. But remember, pressure due to a liquid remains the same. So it means the pressure on each of these, the pressure here is going to be the same, only that the pressure due to the liquid is going to be the same even on the piston, in each piston, only that they are going to be 4. So therefore, that means the force experience is going to be different. So the pressure again is going to be force over area. We want the force applied to each brake. The force applied to each brake. So let's find this force. The pressure remains the same, 1 million is equal to the force divided by the area of each. The area of each is going to be 12 times 10 power minus 4. So this is going to be 100,000, 1 million times 12 exponent minus 4. So this means the force on each is going to be 1,200 newtons. So the answer here is going to be C. The force on each is 1,200 newtons. So the force is going to be C. So I've used just Pascal's principle. Pressure due to a liquid is the same at all points, but the force is going to be changing because the cross-sectional area on the pistons is different. The pressure is the same, but the force changes since the cross-sectional area has changed. That's why I use the same pressure, but a different area. That is Pascal's principle. A rigid cross-sectional, let this be the last on this episode, a rigid cross-shaped structure having 4 arms, POSO, QO, and RO, each 1 meter long, is pivoted at O. Forces act on the ends of the arms and on the midpoints of the arms as shown. What is the magnitude of the resultant moment on the structure about O? Resultant moment. Okay, I'll begin with the torques, those ones which are, the couples, 70 newtons, 70 newtons. Remember, it has 4 arms, each 1 meter long. Each of them is 1 meter long and pivoted at O. Okay, forces act on the ends and on the midpoints. So that means these are the midpoints of this length. So this distance here is going to be 1 meter, because they are 1 meter long. This one here is also 1 meter. These ones are acting at the midpoint, so this is going to be 0.5 up to this one. This is 0.5, 0.5, 0.5, 0.5. Okay. So I'm going to start with the torques. Those ones are constituting it. Moments due to couples. So 70 and 70 is a couple, and it is causing anticlockwise moment. So I will say 70 times the perpendicular distance between them, that is 1. Plus, let me check if there's any other causing anticlockwise moment. Okay, I don't see any other couple. Okay, but I can see forces which are causing anticlockwise moments, which are single forces. We have 30. So I'll say plus 30 times its perpendicular distance from the center, which is 0.5, plus another 30 times its perpendicular distance, 0.5. Then, so this one is done, this is done, this is done, this is done. Then we have 20 plus 20 times perpendicular distance, 0.5. So this is done. I think that is all for anticlockwise moments. Then this is anticlockwise moments, so I will say minus clockwise moments. For clockwise moments, I have 50 times perpendicular distance, 0.5. Then I have 20 times perpendicular distance, 0.5. And I also have this 50 here times perpendicular distance, 0.5. So I'll just check my calculator here. So 70 times 1, that is just 70, plus 30 times 0.5, that is 15, plus 30 times 0.5, that is 15, plus 20 times 0.5, that is 10, minus 50 times 0.5, that is 25, plus 20 times 0.5, that is 10, plus 50 times 0.5, that is 25. So I am getting the resultant here as 50. Is it 50? I have to check this again. Okay, let me repeat this. Let me start with, let me distinguish the moments clearly. So I'm talking about, let me start with clockwise moments. So this is 50 clockwise, 50 clockwise, 20 clockwise. So clockwise moments are going to be 50 times 0.5 plus 50 times 0.5, which is 50 times 1, plus 20 times 0.5. And that is 50 plus 10, which is 60 Newton meters. That is clockwise. Anti-clockwise, we have 70. Oh yeah, this perpendicular distance is we have 70 times the perpendicular distance. So from here up to here it is 1, from here up to here it is 1, so this is going to be 2. Perpendicular distance here it is 2. No, here it is 1 plus 1, the distance here is 2, not 1. So this is 2 meters, okay, so that is times 2 meters plus, I have 20, this 20 here is causing anticlockwise, so that will be 20 times perpendicular distance, which is 0.5. So this one is out, this is out, this is out, then plus 30, so 30 times perpendicular distance, which is 0.5, so this is out, plus another 30 times perpendicular distance 0.5, this is out. So half is 0.5, the length from one end to the other end is 1 meter. Okay, so let's press the calculator here. 70 times 0.5, that is 140, plus 10 for 20 times 0.5 plus 15 plus 15. That is 180. So that is clockwise. So the difference, the resultant, is going to be 180 minus 60, which gives us, I think this is 120 Newton meters. So the answer is going to be C. Okay. So your task is just to identify which one is clockwise, which one is anti-clockwise. As simple as that. So the answer is C. So let's part 7 stop here. See you in part 8. So we have stopped on page 60. Bye bye.